this problem is an example of a system of inequalities that we want to be able to solve, and the best way to solve that is going to be by graphing, having that visual representation. So we have a couple of pieces of information from our problem up here at the top that says Matthew wants to sell laptops and smartphones. He wants to sell at least 12 devices and earn at least $4,500. And then we also are given the system of equations. Sometimes you're going to have to write your own system of equations, but in this one, it's given to you. So we just need to make sure we know what each part represents. So we used, instead of the variables x and y, we use the variables L and S. It doesn't matter which variables you use. This one, it makes it a little self-explanatory as to what is what. L is going to represent the number of laptops sold, and S is going to represent the number of smartphones sold. And one way that I was able to tell was from this very first equation that L plus S has to be greater than or equal to 12. We know he wanted to sell at least 12 devices, so that makes sense for that first equation. Now in my second equation, I can see that I have $4,500 here at the end, and the other two numbers, we weren't actually given in the problem what those two numbers mean, but based on the equation, we can make some interpretations that both of those numbers would be how much Matthew is selling each of those devices for. So 425 means that each laptop is being sold for $425. Because if I multiply $425 times the number of laptops, that's going to help me get my profit. And then very similar for that 125, that each smartphone is sold for $125. So again, you might have to be writing these equations in problems to come, but for now we just wanted to make sure we could dissect these values. And the last value that we want to dissect is this $4,500 represents the total money that Matthew is going to earn. Okay. So our next step is going to be to actually graph our system and to label our axes. So because we didn't use x and y in our equations, we need to make sure we know which value we're talking about that's representing x and which value we're talking about represents y. So again, it does not matter. I'm going to go ahead and assign L to be kind of my x value, since that's the variable that comes first. Again, it does not matter. So I'm going to label my x-axis here as the number of laptops, because that's my x values, and I'm going to assign S to be my y value, which is the number of smartphones. Okay, and I'm leaving space because I am going to have to scale my axes. Now I don't have to get all the way up to 4,500 because I know this is standard form. I know that I can find my intercepts fairly easily by plugging in zeros into my equation to get both my x and y intercepts, because I know my x-intercept is always something comma 0, and my y-intercept is always 0 comma something. So if I take a second and do a little math, a little algebra here, by plugging in my 0 first for S and then again for L, I will see that I get my x-intercept, or in this problem on the left, L will equal about 10.6. I know it's a weird decimal. We get 10.588. I'm just rounding. And I get my y-intercept here when I divide by 125. That one's a little bit better. I get 36. Okay. So those are going to be the biggest values. If I do the same thing with my first equation, that one's a little bit easier to get. But repeating that process, plugging in my zeros, I can see that both of my intercepts in my first equation are going to be 12. Okay, so again, my biggest value that I need to graph is going to be that 36 on my y-axis. So I'm going to decide to scale my y-axis by 4s. and I scaled my x-axis by 2's. Okay, so I can graph my two equations. So my first equation is the purple on the left-hand side. I'm going to graph both of those values. My x and y intercepts are at 12. And I did treat them as equations when I started solving, because we first need to graph the line. And I know it's a solid line because it's a greater than or equal to symbol. And same thing with my second inequality. I'm going to graph my x-intercept is 10.6, so just a little bit more than 10. And my y-intercept is up there at 36, so I'm going to graph that line as well there. Again, I know it's going to be a solid line because it's a greater than or equal to sign. Okay, so from here, we have to determine where we're going to shade, right? We still have these 4 areas. I have 1 here, 2, I have this area over here, 3 and 4. Now, only one of those areas is going to be a correct solution for both of my 2 inequalities. Looking at my first line, my purple line here, that had my intercepts at 12 and 12, I know I want to sell more than 12 devices. So I know that my shading is going to occur up above 12. More than 12 is going to be up here. And same thing with my $4,500. I know I want to make more than $4,500. So that's going to get shaded above this line as well. So we can see that 2 of my areas are shaded but don't overlap, and 1 area is the area that overlaps. So area 2 here is going to be my final solution of my area that I'm going to be shading in. So I'm going to go ahead and make that my final answer. So it will look something like this, with the blue line being the border over here and the purple line being the border over there. Again, if we wanted to check, we can take any point in this area, in my area that I shaded, and I'm going to be selling more than 12 laptops, right? So if I pick a point over here, this would be the point 12, 36. Well, obviously 12 plus 36 is going to be more than 12. And if I multiplied 12 by 425 and multiplied 125 by 36, I'm definitely going to get a number that is bigger than 4,500. So now that I have the area that represents my solutions, only this area 2, nowhere else, I can now answer my questions a little bit easier below. So the first question says, does Matthew meet both of his goals by selling 9 laptops and 6 smartphones? So that's going to make my life really easy if I have my graph, because I can just look for the coordinate points that go with this problem. So again, my number of laptops is X and my smartphones are Y. So I'm going to look to see if 9, 6 is in my shaded area. So if I go up here, 9, 6, it's a little bit hard to tell, but I think it's in area 4. So I think that would not be a solution because it's not in the shaded area. But we always could double check our answer by plugging those numbers into our equation. Let's try. So I have my my inequalities. I just wrote them out so we can remember them. And I know that 9 plus 6, when I plug it into my first inequality, that is going to get me a true statement. 15 is greater than 25. So it meets the criteria for the number of devices that I want to sell, but I need to double check that it meets the criteria for my price. So I'm going to do the same thing and plug in 9 and 6 into my other equation. And when I multiply my price by my number of devices, I do get 4,575, which is greater than or equal to 4,500. So actually, Matthew does meet both. Oh my goodness, he does meet both of his goals. Let's go back up to the graph and look at that one more time. So here's my graph. And we're looking again for that 0.9 comma 6. And again, maybe if I had graphed this correctly in the first place, the 0.9 comma 6, it's not right there, would be closer to 10 in between, and 6 would be right about here. So it is going to be in that shaded area, but good thing we have those equations so that we can double check our answers. Jumping back down to the last question, other natural restrictions that we can have on L and S. This is just, again, kind of getting us to think about the situation. And we know our graph goes on forever and ever. We draw arrows on the end of it. We have 4 quadrants that we look at on a graph. But we know that we can't have fewer than 0 laptops, right? I know my number of laptops is either going to be 0 or it's going to be greater than 0, right? I can have 1, 2, 3. I can't have negative laptops. And same thing with S. S has to be greater than or equal to 0. So those might be natural restrictions that you guys thought of on your own, but they should technically be part of our system of equations. And both of these two equations, those are just going to be a horizontal and vertical line. My L, since my L values represent my X values, that's going to be a vertical line. And since my S values represent my Y values, that's going to be a horizontal line, which are just my X and Y axes. So again, if I go up to the top of or if I go back up to my graph here, my restrictions, if I'm adding those into my graph, I actually am graphing that I can't pass this or this on my graph. So I'm going to change some of my pink shading to not include this little area down here or that little area up there. So again, one more time, my final answer can only be in this first quadrant. We have some boundaries here. That just makes sense for the problem. Again, you might have already thought about that, but that is the official crazy system of equations. It's technically 4 equations in one system.